Hello everyone, I'm A. Sriniti. I'm currently pursuing BE in Computer Science Engineering at Kongunadu College of Engineering and Technology. I'm going to share my views on operating system as well as how it works, what are the things we are going to see us, what are the types in it, what are the functions in it, and etc. Let us see in detail. First we'll know what is OS. Introduction about operating system. It is a system software which provides and manages hardware as well as the software resources. It provides common services for computer programs also. It acts as an interface between the user and the computer hardware. Next is examples of operating system. They are Windows, Mac OS, Linux, Android, iOS. And next, functions of operating system. It is process management, memory management, file system management, device management, user interface, security and access control, etc. Process management deals with handling running applications and allocated resources, whereas memory management deals with managing RAM and ensures efficient use. File system management involves organizing and control access to data storage. Device management includes controls hardware like printers, keyboards, and storage. User interface is providing GUI or CLI command. Security and access control leads to protect against unauthorized access. Types of operating system. They are batch OS, time sharing OS, distributed, real time, embedded, etc. Components. And next, what we are going to see is the kernel. The kernel is the core part of the OS, which is responsible for managing system resources like CPU, memory, and devices. It interacts directly with the hardware and provides essential services to applications. There are two types of kernel. They are monolithic and microkernel. The monolithic kernel is the entire OS runs in a single layer, whereas microkernel is when the essential functions run in the kernel with other services in user space. Example of monolithic kernel is Linux, whereas example of microkernel is the Minix. And next is the process management. In process management, it manages the execution of process and allocates CPU time, handles multiple tasking, and manages process scheduling. Uses techniques like multi-threading and process synchronization. And the next is the memory management. In memory management, it controls how random access memory is allocated to the processes, and it also implements virtual memory to extend RAM using disk storage. It also prevents memory leaks and manages swapping. This is the role of the memory management in operating system. And next is the once again file system management. In file system management, it organizes and stores files on the storage devices. It handles file permission, it handles access control, and also the storage allocation. Examples of file system management include NTFS in Windows, X4 in Linux, and APFS in macOS. And the next is the device management. In device management, the control input output devices like keyboards, printers, and USB drivers are used. It uses the device drivers to communicate with the hardware. To communicate with the hardware, we use the device management and that are the functions of the device management in the operating system. And then it is the user interface, which is known as UI. The user interface, it provides interaction between the user and system, whereas we have seen in the first slide, operating system is the interface between the user and the computer hardware. Here user interface denotes the interaction between user and the system. And next is the what two types include in a user interface. They are graphical user interface for Windows and Mac OS and command line interface CLI for Linux terminal, command prompt, etc. And next is the security and access control. Security and access control deals with it protects system from threats like malware and unauthorized access. It also implements user authentication, encryption, and firewalls. It enforces permission for files and processes. And the next one is Networking and communication. It manages network connections like Wi-Fi, Ethernet, Bluetooth, etc. And it also supports internet protocols like TCP protocol, HTTP protocol, DHCP protocol, and FTP protocol. And next is the advantages of OS. The advantages of operating system are it is user friendly interface, it provides multitasking, it involves resource management, it deals with security and protection, it also has file management, it deals with hardware and software compatibility, it handles the error, and it gives us the network support. These are the main advantages of using operating system, and it is widely used among all for these kind of advantages they gave us. And the next is disadvantages of OS. The operating system is very high cost. For example, for some OS like Windows and Mac OS, and security vulnerabilities are also present on the operating system. That is, it prone to malware and hacking. Next, there are system crashes and failures. And next, learning and management complexities. It is hardware dependency. That is, some OS work only on specific hardware. Next, it is resource consumption like high RAM and CPU usage. And software compatibility issues. Some programs work only on specific OS. Frequent updates and maintenance are needed for the operating system maintenance. Applications of OS. OS is widely used among all of us in daily life, and some of the applications of OS are listed here. They are personal computing, mobile devices, servers and networks, embedded systems, real time systems, cloud computing, supercomputing, IoT, Internet of Things, edge computing, cybersecurity, and also the forensics. These are the applications of OS that is widely used among now and also then. And future trends in OS. The future trends in OS are AI driven operating system, which deals with intelligent process management and automation, and AI powered security and threat detection. Next is edge computing integration. OS designed for real time processing on edge devices, low latency computing for IoT, quantum computing OS, development of OS for quantum process, and new algorithms for quantum parallelism. Yeah, and blockchain based OS, cloud native operating system, IoT centric OS. IoT centric OS deals with lightweight and energy efficient OS for smart devices. Cloud native operating systems deals with OS optimized for cloud environment and serverless computing integration. Blockchain based OS deals with decentralized operating system for security and transparency secure identity management. Thank you.